All right, get rid of my curve. Now you can draw these out if you'd like to, but it doesn't matter if you're using a left endpoint or a right endpoint. It doesn't matter what the picture looks like. This is really going to be kind of your formula for all of these. All right, so the trickiest thing I think is actually finding the right endpoint. So we want the area from -3 to 2. Okay, so the endpoint, which I would write off somewhere else, x sub I is, well, I want to start at -3. So you're going to start with your, so here, let's write this down more as a rule. So your starting point plus some little change in x. I want to get to the right endpoint. So plus, well, really delta x. So think about that picture there. This endpoint right here, if I'm starting here and I want this point, if this is my A, I have to add in whatever delta x is to get it up here. And delta x is your b minus a over n. But I'm going to keep it a little simpler and put delta x, or dx, sorry. Alright, so we have our dx, and it depends on who you look at. Sometimes it's dx and sometimes it's delta x, change in x. So what we need is our dx, which is our b minus a. So here's a, here's b. So 2 minus -3 is 5. And then we want to do this for every single number. So not just, oh, sorry, don't forget to put it over n. B minus a is 5 over n. So that would be just the first endpoint, but I want to add in this number each time. I want this x sub I to change. So what I have to do is I have to multiply it by I to make it move. In other words, n is just a number. It's going to number that's going to go to infinity. I want to add this a bunch of different times. There's my f. That's my x sub I. Okay. So the sum of, so it's supposed to be f of x sub I, so f of -3 plus 5 over n times I. So the quick thing that I forgot over here for a second is it's not just delta x. You don't want to do that once. It's not just dx, it's dx times I. That allows it to move each time. That's where the I comes into in the equation. And so it's f of x sub I times dx. And in this case, it's not dx times I, it's just 5 over n. Alright, so what we have to do is find f of this. So f is 3 times whatever x is, so -3 plus 5i over n plus 5. All of that times 5 over n out back. Alright, so from here, all we got to do is kind of clean things up a little bit. So this is -9 plus 5 would be -4 plus 15i over n. That's just the inside here. All of this is still times 5 over n, which gives us the sum of -20 over n plus 15i over n squared. Okay, and we're going from I equals 1 to n. Alright, now the thing to notice is I is the variable in this equation, not n. So when we look at the -20 over n, this is a constant as far as I is concerned. So all we do to find that part is just, it's -20 over n constant times n. The n's cancel out. Pretty sweet. And the next part is going to be plus 15, well, over n squared. Well, what's I? Well, you have to look back up top. We just did some of these problems on the page before. This is n times n plus 1 over 2. It's just one of those formulas. Now you'll notice here that always you're going to have the same number of n's on top as on bottom. So I want to simplify this a little bit. We end up, we got a little bit of kind of messiness over here. So we have -20 plus, well, this would be 15n squared plus 15n. If I want to do that both separately, that's fine. But what I have to do in the end, trying to get this in here, is remember I'm taking the limit as n goes to infinity because I want to come up with an infinite number of rectangles. N is the number of rectangles that you're seeing. So if we're doing an infinite number of rectangles, we're taking this limit. Well, the limit of 20 is 20. I'm looking at the bounds here. I'm looking at the powers, same top and bottom. So we're just looking at the coefficients. So 15 over 2. So this is 7.5 minus 20, basically, is my answer. Or a negative 12.5. And this is the actual area of the curve. It's negative 12.5. That's really just it. You're going to get an actual number. Now you might wonder, well, why is it negative? You shouldn't have an area that is negative. So let's think more about what this picture's doing here. For x plus 5. 1, 2, 3, 4, 5. And we get a pretty steep picture, right? What we're going to do here, if we look at it from negative 3 to 2, is, I don't know if I drew my picture good enough. 1, 2, 3 over 1. 1, 2, 3 over 1. Yeah, it's just not far enough down. You're going to end up having more area under the curve, under the graph, than you will have over the graph. So my graph was steep, but it wasn't steep enough. So because you have this huge chunk of area under the curve, you end up with more negative area than you have positive area. That might sound like a crazy statement to say that you have negative area and positive area, but what you're going to end up relating this to is really the antiderivative. And sometimes you want to come up with the area on the curve, and sometimes it just means something else. It might be that the area of the curve represents your speed, and if your speed is negative, that means you're going backwards. So a negative area on the curve is okay in this case. Let's try one more example here. All right, we're going to try example 11. Now, this is the antiderivative symbol, as you can kind of tell, and we're going to find that they kind of mean the same thing sometimes. Now, you'll notice that we've got numbers on the ends here. So this is really asking for, because there's numbers there, not just the antiderivative. And you could find the antiderivative of this using the power rule. But it's looking for, and we know this because of the numbers, the area of the curve from negative 4 to 0. Alright, so that's what we need to know. We need to know dx, which is going to be b minus a, so 0 minus 4, 0 minus negative 4, 4 over n. This will be our a, and this will be our b. Start to finish, kind of a little bit backwards from what you might think, low to high. Okay, so there's our dx, and we need our x sub I, which is our start, which is negative 4, plus our dx, 4 over n, times I. Okay, now we have to do is f of x sub I, which means we have to plug this in for that. We're doing the sum from I equals 1 to infinity, or to n, we're going for now. It'll be eventually infinity. And we got to plug this into our f. So negative 4 plus 4i over n squared plus 3, all of that times the width, the dx, 4 over n. Now, this obviously is a little bit trickier because you got to FOIL all this out. So this ends up being 16 plus 3 is 19. And then we end up with a negative 16i and another negative 16i, so negative 30i over 32, sorry. I over n, and then the n is going to be a plus 16 I squared over n squared, all of that multiplied by 4 over n. Alright, so in the end we have our 19, negative 30, 19 times 4, 76 over n, minus 128 I over n squared, and then plus 64 I squared over n to the third. Now, all we're going to do is we're going to use our rules for each of these separately. This is a constant, so we lose the sum the second we start using the rules. So 76, because you multiply by the ends, minus 128i, which is n times n plus 1 over 2. Don't forget we have an n squared on the bottom. And you notice all of this is going to be n squared. The 1 doesn't matter. You get a 128 over 2. That's the part that matters. Plus 64. So we have n times n plus 1 times 2n plus 1 over 6. And then we have an n cubed on the bottom. Now, this is the area of the curve for n number of rectangles. What we want to do is take the limit as n approaches infinity of all that fun stuff. Well, the first part's just 76 minus, okay, well, the n squareds on top and the n squared on bottom, they're going to cancel out. 128 over 2, or 64. Plus, and over here, you might be tempted to say, okay, well, 64 and 6 is n times n times n is n cubed, but this 2 is going to throw that off. So this is 64 times 2 divided by 6. Well, 2 and the 6, they end up making like a 3, so it's 64 over 3. Add those together, and you get the true area under the curve. Now, a quick way you can check all of that is your calculator, especially a newer calculator, can do this. So if you have a new calculator, you go Alpha Window, and if you go down to number 4, function integral, you end up getting this fun thing, and you can just write it in. -4 to 0, x squared plus 3. Make sure you put dx on the end. Hit enter, and you've got the same answer that you should have gotten by hand. Drawbacks to this: first off, it doesn't get at why this number is what it is. You're adding up an infinite number of points under the curve. If you don't really go through the whole process, if you don't practice it, you won't really understand what's happening when you're doing these problems. So you really have to be able to get through a couple of these on your own before trying to skip any steps. Other things, you might not have this on the calculator portion of a test. You might have a non-calculator portion. You might have to find that area in the curve. If you can't use this, don't get too dependent on it. But that's the main idea.